All right, let's look at this last example in this section. Use Desmos to approximate the intervals of increase, decrease, and intervals of concavity for this function. All right, so I've already got it plugged into Desmos, and we can look at it and see it looks like this up here is a maximum, and then so it's decreasing along here. It's increasing along here. But let's see, does it have another maximum or minimum out here? That can be kind of hard to tell. So here's what I'm going to do. I'm going to put in, notice I've got it written in as f of x. If I put in f prime of x, that gives me the derivative. So I'm going to turn the original function off for a moment. If you look at this and you look at the places where the derivative is equal to 0, the derivative is equal to 0 here at 0.291. So let's write that up here. F prime of x equals 0 at x equals 0.291. And let's see, is there anywhere else? It looks like back here. Yeah, x equals negative 2.291. Is there anywhere else? I don't think so. It looks like it has an asymptote. Yeah, it looks like this is an asymptote where it's approaching 0, but if I come over far enough, I could probably make it say 0, but that's from round-off error. This is an asymptote. If you look back at the original problem here, as x goes to 0, as x goes to negative infinity, the function is going to go to 0. So it's got an asymptote there. The only places where it really touches 0 are here and here. So let's see. That should let us answer the first part to determine the intervals of increase and decrease. Let's turn the original function back on and zoom back over here where we can see it. So from looking at this, it's increasing. You know what? Maybe I should draw a real number line here. We've got negative 2.291, then 0.291. And if you look at what the graph is doing, whoops. If you look at what the graph is doing back here, it's decreasing. And then, that might be difficult to see. If we turn the derivative on and we look at it back here on this side, if we zoom way in, you can see that the derivative there in green is negative. So that tells us that this function is decreasing, even though it's kind of hard to see because it's practically flat there. But it's decreasing until you get to here. So the function is decreasing, f prime is negative. I've got all this space, let me actually use it. F prime is negative, whoops. Then in between, it's increasing because the derivative is positive. And then over here, once you get past this point, 0.291, the function is decreasing, and the derivative is negative. So we'd say it's increasing on, let's see, negative 2.291 to 0.291, and I would use brackets there. And it's decreasing on, let's see, negative infinity to negative 2.291, and from 0.291 to infinity. All right, now let's look at the let's look at the concavity. So for concavity, what we need to do is look at f double prime of x. So we get this, and we can see that the concavity, the second derivative changes sign here and here. So let's see, concavity second derivative equals 0 when, let's see, x equals, let's put these in order. Back over here when x equals negative 0.248 and when x is equal to 0.763. So if I do my number line here, let's see, is that all? I think so, yeah. All right, so if you look at it, back here, I'm sorry, you can't read what you can't see what I'm writing. So if we look at this, back in this region over here, the second derivative is positive. In the middle, it's negative, and once you get past this point here, the 0.763, second derivative is positive again. So remember, that tells us that the function concavity, let's see, pluses are smiles and minuses are frowns. So this thing is concave up on minus infinity to minus 0.248, and again on 0.763 to infinity. It's concave down on, well, in the middle, from negative 0.248 to 0.763. All right, so using Desmos, it can really help us out here. This function, I tried to pick a function that would be an ugly thing to take the derivative of. In all honesty, this one probably wouldn't have been that bad. We'd have to use the quotient rule on it, so it wouldn't be that bad. But we can definitely use Desmos to do this and get these approximations. And I guess I should put a box around my answers. These are my intervals of increase and decrease. And these are my intervals of concavity. All right, I think that'll do it for this section.